Welcome to another podcast. This episode, we're going to be taking a look at how to calculate the limits of a graph. Before we start that, though, I just want to remind you what the definition of a limit actually is. So what we say is that the limit as x approaches a of the function f of x is equal to the limit L if the limit as x approaches a from the left equals the limit as x approaches a from the right, and both of those limits are equal to L. Remember that we call these the one-sided limits. And then this is the full limit, or the complete limit, or the two-sided limit. So the limit exists if, as we approach the point from the left and the right, we're getting the same value. Otherwise, the limit doesn't exist. And we'll just usually write D and E for doesn't exist. So I have a graph over here to the left-hand side, and I want to apply this definition of the one-sided limits to determine whether the limit exists at certain points and what the limit is at those points. So let's just go ahead and start with, let's do the limit as x goes to 3. So this is the graph of the function f of x, so the graph in black here. This is f of x. And I want to look at the limit as x goes to 3. So in order to do this, I need to know what the limit is from the left and the right as x approaches 3. So the limit as x approaches 3 from the right, so we're coming in, here's x equal to 3, we're approaching it from the right, the limit is the y value. So what's the y value at the point 3 when I approach from the right? Well, the y value is 0. So the limit of this approaching from the right is 0, and the limit approaching from the left, so if I get to the left of 3, so I'm on the function over here, and I approach x equal to 3 from the left, the y value at that point is 2. So the left-handed limit is equal to 2. And because these are different, then I can go back and say, okay, the limit from the left, limit from the right don't match up, so this limit does not exist. And that's the correct way that you would write that. The limit as x goes to 3 of the function f of x does not exist. Similarly, the limit as x goes to 2 of f of x does not exist either. The reason that both of these, you can see clearly here at 2, the points actually defined way down here and the jumps from here to here. And so anytime you have a jump discontinuity, that's what these are called, so jumps in the graph lead to points where the limit of the function doesn't exist. That's what's going on here. In particular, if we were to do the one-sided limits, the limit as x goes to 2 from the right, so we're approaching 2 from the right, the y value there is 3. So the limit of the function is 3 from the right, but as we come in to 2 from the left, you can see clearly here that coming in from the left, as we approach x equal to 2, our y value is 1. And so don't confuse limits with the actual function value, because for these two problems, you can see that the function value at 2, so at 2, the function value is actually defined way down here. The function value at 2 is actually -1. So that doesn't match either of the limits. And that doesn't necessarily have to be the case. The limit does not have to match the function value. So limits do not always match the function value. So let's do one more limit here. Let's look at the limit as x approaches -2. So -2 is over here. As I approach -2 from the right, so as I approach from the right, the y value is 1. And as I approach from the left, the y value is also 1. So in both directions, we get 1 as our limit. Notice that the difference, even though the function value is not defined there, because there's not a jump, the limit at that point exists. And it's the same way. You can see that the limit as x approaches 1. So as we approach 1 from the left and 1 from the right, the y value in both cases is 2. And so you can see that the limit of the function as we approach 1 from both sides is 2, so the limit exists and it's 2. So we only get that the limit didn't exist in the case where we had these jumps between 3 and between 2. Everywhere else on this graph that we can see, the limits are going to exist. Now, that doesn't necessarily mean they match the function values, but the limits do exist at those points. All right, we're going to be looking at several examples of calculating limits via graph throughout the semester, and so you need to get a good hold on how to look at a limit approaching from the left, a limit approaching from the right, and being able to tell whether or not it matches the function value or doesn't, and whether or not the limit exists at that point. All right, thank you for watching.